Yeah, the resistance of a given wire is obtained by measuring the current flowing in it and the potential difference applied across it. So basically, the potential difference that is equal to the product of the current and the resistance. So this is the Ohm's law. Now what we need to find is, we have to find the error in the value of resistance, and using the options we can see that this is percentage. So basically we are supposed to find the percentage error in the value of the resistance, which means this. Now how do we find this? What have been given to us, that the percentage errors in the measurement of current and voltage are 3% each. So if I observe from the Ohm's law, I can write R as delta V by I, where delta V stands for the potential difference. Right now, the formulas or the rules which we had done, so whenever the formula is of this type, the delta R by R would be delta V by V plus delta I by I. Now if I multiply the whole thing by 100, so we will get the percentage errors. So this delta V by V multiplied by 100, this is nothing but 3%. Similarly, the error, percentage error in the current is also 3%. So overall the total error in the resistance in percentage terms is 6%, which means the answer is option number 2. Now Ayush, in your worksheet or the answer, I can see that you have marked option number 4. So just cross check what is the mistake which you have done. The answer to this question is option number 2, 6%. Now for the second question, Smera, you have not attempted this question, but others have solved it correctly. But even in all of the solutions of the others, there are certain errors. So just have a look at the solution and then you can cross check your approach. So this was our question number 2, where it is given the formula for time period of a pendulum, with this capital T stands for the time period, and that is equal to 2 pi square root of L by G. L is the length of the pendulum, whereas G is the acceleration due to gravity. So it's given to us that the value of L is 20 centimeters, known to 1 millimeter accuracy. So 1 millimeter stands for the uncertainty, absolute uncertainty in the measurement of length. And we are using, let's say, a timepiece, or in this case a wristwatch, which has a resolution of 1 second, which means this delta T, which means the uncertainty in the measurement of time, this is 1 second. And what we are using is, we are taking 100 oscillations of the pendulum, and the total time is found out to be 90 seconds, which means for 100 oscillations the total time taken is 90 seconds. Let's say if we need to find the time period, which means of one oscillation, so that would be 90 divided by 100. But let's see how to solve this question now. We have to find accuracy in the determination of G. So basically, if you look at the options, we need the percentage error in the measurement of G. So let us write down the formula. T is equal to 2 pi square root of L by G. Now since we are supposed to find G, let's isolate the value of G. So G can be written as directly proportional to L divided by T square. Now since we have got the formula, so I can write delta G by G, that is equal to delta L by L plus 2 times delta capital T divided by capital T. Now see, this is the catch here. Delta capital T stands for the uncertainty in the measurement of time period, and time period is only for one oscillation, right? Okay, so let's, if T is the total time, which in this case is 90 seconds, so the total time period, which means the time taken for one oscillation, this is given by T divided by N, where T is the total time and N stands for the number of oscillations, right? So this is the linear relation between capital T and small t. So I can write delta T capital T by capital T, that is equal to delta T by small t, right? So we have to substitute this value over here. Let's see what do we get. Let me scroll this down. This is equal to delta L by L plus 2 times delta T divided by small t. Now delta t is the uncertainty in the measurement of time. So if we scroll up and see the question, this delta t is 1 seconds or uncertainty while we are using this wristwatch. So delta t can be put as 1, and t is the total time which is measured by this wristwatch, and that is 90 seconds. So I put small t as 90 seconds. Now delta L was the uncertainty in the measurement of length, which was 1 mm divided by length was 20 centimeters, plus 2 into 1 over 90. Now let's convert now mm and centimeters into meter so as to make it in the same unit. So 1 mm can be written as 10 to the power minus 3 meters divided by 20 centimeters can be written as 20 into 10 to the power minus 2 meters, and this will be 2 by 90. So if I solve for the whole thing, so I can write here 0.005, and this right hand term is 0.022. So if I add the 2, I'll get 0.027. Now in percentage terms, if I multiply this by 100, so I will get 2.7%, and this can be approximated to 3%, which is the answer to your question, which is the percentage uncertainty in the measurement of G. This is your 3%. Let's see what is the option. Okay, so option number 4 is the correct answer for this. So for this question, Vaibhav, Saumil and Ayush, although you have got the right answer, please cross check your approach one more time. Now coming to question number 3, Smera, Vaibhav and Saumil, all of you have attempted this question correctly, but please cross check your approach when I show you the solution. Ayush, you have done it wrong, so just see. So you can solve it one more time and then see what can be the answer. So in this question, it's given that a student measures the time period of 100 oscillations of a simple pendulum 4 times, and the data sets, the 4 values of times are given to you. Now pay attention that these values are not the time period. Like in the previous question I told you, see the time period which is given by capital D, that can be written as the total time divided by n, where n stands for the number of oscillations. Here n is 100, and the small t's values are given to you 90, 91, 95 and 92. So since the experiment has been performed 4 times, that's why you are getting 4 different values of the time. Now if the minimum division in the measuring clock is 1 seconds, which means delta t is 1, so we have to find out the reported mean time, right? So first, see, if you look at the options, this 92 is common among all of this, so might as well not solve it. But for your explanation, what we can do is we take all of the 4 values and take the average. So 90 plus 91 plus 95 plus 92 and divided by 4. If you solve this, you will get 92 seconds. So that is the mean time. Now we have to incorporate the uncertainty as well. So consider the 4 values. Let's say x1 is 90 seconds, the first value of time, x2 is 91, x3 is 95 and x4 is 92, and the average value of this is 92, which we just found out. Now to find out the absolute value of the error, which means let's say delta x, this which we need to find out. So for that, what we will do, we will find the individual errors for a specific value. So let's say consider the first value of 90. What we will do is we will find out how far it is from the average. So let's say if I want to find delta x1, so that will be modulus of the value of x1 minus the average. So this can be written as x1 is 90 and the average is 92. So if I solve this, I will get 2. Now the negative sign would vanish because of this modulus sign. Similarly, delta x2 would stand for how far is this value from the average. So that will be 91 minus 92, which will give us 1. Similarly, we find out the delta x3. how far is this x3 from the average value, which is 95 minus 92, which will give you 3, and delta x4 is 92 minus 92, which is 0. Now to find out the total absolute uncertainty, we will take the average of the individual uncertainty. So delta x would be this 2 plus 1 plus 3 plus 0 divided by 4. So if I solve for this, I'll get 6 by 4, and 6 by 4 is nothing but 1.5. Now 1.5 can be approximated to 2, so the actual answer, which is the reported mean time, that will be 92, which is the average value, plus the uncertainty, plus minus 2 seconds. So let's see which of the options gives this answer. 92 plus minus 2, option number 2, that is the correct answer. Now question number 4, which Vaibhav, Saumil, Ayush, you have done correctly. Smera, you have not attempted it. So let's see this question number 4.